Hi, welcome to my video on the opposite of a rational expression. But before I start this video, I'd like to explain that in the video adding rational expressions with different denominators, I did not do the workings for number 6 on page 4 of 6. I apologize for this omission. So I'll do that now. That's the video that's just before this one. So let's add these two expressions. And before we add, we should make sure that our denominators are factored. And x squared plus 4x, x is the GCF, x squared divided by x is x, plus 4x divided by x is plus 4. And x squared minus 4x, x is the GCF, x squared divided by x is x, negative 4x divided by x is negative 4. So the LCD is x as a factor, x plus 4 is a factor, and over here, x minus 4 is a factor. So that's the LCD. That means I will multiply this fraction by x minus 4 over x minus 4, and this one, I have to multiply it by x plus 4. Again, note, x and x plus 4 are here. I need an extra x minus 4, top and bottom. I have an x and an x minus 4, and I need an x plus 4 to multiply to give you the LCD, so I had to put it on the tops. So now I have going to multiply to get equivalent fractions. So the denominator that I'm going to use is this one, x times x plus 4, and x times x plus 4 times x minus 4. So the LCD, no matter what this is, if I do it right, keep the LCD for both of these the same. So let's multiply x minus 4 by x minus 3 by FOIL. So x times x, x squared. The last terms, negative 4, negative 3 is plus 12. And the outside is negative 3x. The inside is negative 4x. So negative 3, negative 4 is negative 7x. So I'm multiplying fast without writing down everything. Negative 5 times x is negative 5x. Negative 5 times positive 20 is a negative 20. So I write down the LCD, because if you have the common denominators, you keep one denominator, and you add up. So x squared is just an x squared. Negative 7 add on negative 5 is a negative 12x, and positive 12 negative 20 is a negative 8. And can we factor this? Can the factors of 8 are 8 times 1 and 4 times 2. So the factors of 8, no matter what you do, will never give you a negative 12. So that's the problem that I omitted on the previous video on adding rational expressions with different denominators. Just check it out to make sure. Now let's start the video that I wanted to do, opposites of a rational expression. Opposites of a rational expressions. So when we do opposites, two polynomial expressions are the opposite of each other if their sum is 0. Note the sign of each term is changed. So if I have a polynomial that's 4 over 5, I make it negative 4 over 5, which is the opposite. So I change the sign of the numerator. And if we add, that's sum right there, if we add 4x, add on negative 4 over 5, add on negative 4 over 5. Let's keep the denominator, and you add those, you get a 0, so 0 over 5 is 0. The opposite of x subtract 2 is negative x plus 2. So we change all the signs. So x minus 2, negative x plus 2, add x and negative x is 0, negative 2 and 2 is 0. And the opposite of x squared minus x plus 3 is a negative x squared plus x minus 3. So we change all the signs. Make that a negative, make that a positive, make that a negative. And so when we add all those up, and I could write them all down here, but just add these up, I get 0, negative x and x is 0, positive 3, and negative 3 is a 0 when I add. The opposite of a negative 8 is a plus 8. So when I add, I get 0. The opposite of a negative 2 plus 7 is 2x minus 7. Negative 2x add on 2x is 0. Positive 7 add on negative 7 is 0. And 2x minus 9, opposite is negative 2x plus 9. And you add 2 and negative, you add 2x and negative 2x, you get a 0. You add negative 9, positive 9, you get a 0. So the sum is 0. And the opposite of a negative 3 over 7 is a positive 3 over 7. So negative 3 plus 3 is 0 over 7, which is 0. So let's look at rational expressions. Two rational expressions are opposites of each other if their sum is 0. It's the same idea. Opposites are when you have a sum of 0. In rational expressions, opposites have their numerator, the numerator signs change, but not their denominator. So we'll make not the denominator signs. So let's look. So to get the opposite of a fraction or a rational expression, we change the numerator signs, but not the denominator. Here we go. Rational expressions, 1/2. Opposite is negative 1/2. And the sum is 0. So if you add those up, you get 1/2 add on negative 1/2 is 1, add on negative 1 is 0 over 2, or 0. Opposite of a negative 3 over x is a positive 3 over x. Again, add negative 3, and 3 is 0 over x, which is 0. The opposite of x minus 10 over x is a negative x plus 10 over x. Positive becomes a negative, negative becomes a positive. Again, when you add x and x, negative 10 and 10, you get 0 over x, which is 0. The opposite of this rational expression, 2x, opposite is negative 2, plus 4, opposite is negative 4, all over x minus 1. Notice the denominator signs are not changed, only the numerator signs. Negative 2 add on, 2x add on negative 2x is 0. 4 add on negative 4 is 0, so 0 over x minus 1 is 0. And this rational expression, opposite of a negative 7x is 7x. Opposite of a plus 3 is a minus 3. All over 9x plus 2. So again, I change the signs of the numerator, not the denominator. Negative 7x add on 7x is 0. Positive 3 add on negative 3 is 0. All over 9x plus 2, and that gives me a 0. And the opposite, negative, positive x squared, negative x squared. Opposite of a negative x, positive x. Opposite of a plus 6, minus 6. All over the denominator. We do not change the denominator. And again, when we add x squared and negative x squared, 0. Negative x and plus x is 0. Positive 6, negative 6 is 0. All over negative 4x minus 7. 0 divided by that expression is 0. And let's continue with more practice. So, to the page here now. Again, we're looking at the opposite of rational expressions. So what do we mean by opposite in a rational expression? We change the signs of the numerator, but not the denominator. So pause your video, work out these, and play back to see if you're right. The opposite is negative x over 3. The opposite is positive 4 over x minus 2. The opposite is negative x plus 6 over x. Notice you change the numerator. Opposite, change the numerator. Opposite, change the numerator. Opposite, but notice the denominator didn't change the signs. Number 4, I have a negative x squared minus 2x. It's the opposite. And don't change your denominator. The opposite is negative 3x plus 1 over negative x minus 9. Now I'm only concerned with adding on the opposite right now, making these two signs the opposite of each other. I'm not concerned with the negative and the leading term. Number 6, opposite is positive x plus 7 all over 3x minus 1. Opposite, positive x, opposite, positive 7. Don't change your denominator. Number 7, I have x squared, I have a negative x squared. Negative 4x plus 4x minus 2 plus 2 all over denominator. Don't only change these signs here, not the denominator. Number 8, opposite of negative 5x, positive 5x. Opposite of subtract 6, add 6. All over x squared minus 4. Number 9, opposites is a positive, negative, negative. So that's a positive x squared, negative 10x, subtract 6x, subtract 6, all over x squared minus 4x squared minus x. So I change, make that a positive, make that a negative, make that a negative, and don't change the denominator. Number 10, the opposite is a negative 11x minus 3. And you don't change your denominator. Let your denominator stay as is. Opposite of 11x, negative 11x, plus 3, minus 3. Don't change your denominator. And number 11, opposite of 2x squared is negative 2x squared. Opposite of plus 8x, minus 8x. Opposite of a negative 11, add 11. And you don't change the signs of your denominator. So that's adding on the opposite of a rational question, which I will do every time that I have subtraction with fractions. And that will come up in the next video, how we're going to subtract fractions. If you like my video, click the like button, the subscribe button, the notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel. And my YouTube channel is called Math Fully Explained. Thank you for viewing my video. Bye-bye.